بسم الله الرحمن الرحيم الحمد لله رب العالمين الذي بنعمته تتم الصالحات. Ladies and gentlemen, today inshallah starting with the workshop with the visiting Prof Norhana Arsad. I will give a previous biography for Prof Norhana. Mashallah, the biography is very long, therefore I will take spot point about this biography. Prof. Dr. Norhana Arsad is an academic and researcher with wealth of experience in photonics engineering. She is currently the Deputy Dean of Research and Innovation and also a professor of photonics in the Department of Electronic and System Engineering at the Faculty of Engineering and Built Environment in UKM. She read her baccalaureate in engineering in computer and communication system and Master of Science in Communication and Network from UPM in 2000 and 2003, respectively. She completed her PhD degree from the University of Strathclyde in Glasgow, UK, with specialization in photonics and optical spectroscopy, with background that compares computer, communication, and photonics engineering, and she unique perspective of fundamental and applied research in photonics engineering. Her niche in design, fiber, laser system, and gas spectroscopy, and healthcare and smart systems. She has developed several cutting-edge technology that have the potential of revolution in a variety of scatter by phasing and base idea of photonics with assistive artificial intelligence technology. Her professional network cover many countries such as China, Japan, Korea, Italy, Iraq, Romania, Oman, and Turkey. She has registered 28 intellectual properties, including in Okobia, which was licensed in 2019. She has authorized and present over 180 publishing, including high-impact journal books, chapter, technical report, and proceeding. As a project leader and co-researcher, she has managed to secure grant related to phonetic technology amount to 1,555 ringgit. That's approach around $345,000. MashaAllah. Norhana has also supervised more than 30 postgraduate students, MSc and PhD, from local and international institutions in related research area. Also, I need apply focusing about cooperation for Prof. Norhana with our department. I cooperated with Prof. Norhana from 6 years ago. We supervised with 3 PhD students, and now we are supervised with 4th students from our department, Mercy Yasamin. And Prof. Norhana assistance with funding to publish paper with rank Q1 for many my students, such as now give fund for Mers Zainab, PhD students from our department. Therefore, thank you very much, Prof, for cooperation with our college. And now take your time with your lecture, and then we'll give about 15 minutes to discuss from the attendance of your lecture. Thank you very much. Take your time, Prof. Share.
Okay, Assalamualaikum and good afternoon.
Good afternoon.
I think in Baghdad, in Iraq, is in morning, right? Okay, Prof, can you hear me? Hello.
Hello, Prof. Share your presentation, Prof.
Yes. Okay. Can you hear me?
Yes, very clear.
Yes. Okay. So allow me to switch off my video first. Okay. First of all, I would like to thank you, Prof. Yousif,
Yes.
for
Okay.
inviting me for
ليش ما ادري
today
شلون
a very short lecture. Actually, very much
نشارك هنا
appreciate
نشوف.
with the initiative. This is, I think, is one of our collaboration. A part of
نشارك الشمس ليش ما ادري
we
شلون.
supervising many students so far, and thank you for the opportunity given throughout our collaboration. So today I'm going to share about optical communication, which is one of my subject, teaching subject in Universiti Kebangsaan, Malaysia. A very gentle and introduction about myself. I'm from Malaysia, and then this is one of the subject, my favorite subject, optical communication. So before that, I think all of us have heard this broadband and narrowband. Recently, we hear the word broadband. What does the broadband mean? So the motivation of using for using the optical fiber system is to develop optical fiber communication system started with the invention of the laser in the early 1960s. So the operational characteristic of this device encourage researcher to examine the optical spectrum as an extension of the radio and microwave spectrum to provide transmission link with extremely high capacity, meaning that with the fiber optics, we can go further, more distant that we can get. So as research progressed, it became clear that many complex problems stood in the way of achieving such as super broadband communication system. However, it was also noted that other property of the optical fiber gave them a number of inherent costs and operational advantage over copper wire and make them highly attractive for simple on-off key link. Yeah? So there's many advantages why you use the optical fiber optics. One, because the fiber optic have lower transmission losses compared to copper wire, meaning that the data can be sent over longer distance, hence reducing the number of intermediate repeaters needed for this span. So because when you walk very far, very longer hour, you will get tired. So with this, we have to use the repeater or amplifier to amplify the signal. Okay. So other than that, when you use the fiber optic, large information capacity, meaning that optical fiber have wider bandwidth than copper wire. So more information can be sent over one single physical line. So this property result in a decreased amount of number of physical line needed for sending
Excuse me,
a
Prof.
certain amount of information. Yes, can you hear?
Yeah, just make a presentation as a slideshow.
So this is the advantages why we use the optical communication. Optical communication. So long transmission distance, large information capacity, and very small size and low weight. And most importantly is immunity to electrical interference. So this is a special feature for the fiber optics. So when it immune to the electrical interference, so it will enhance the safety. The safety. So why the optical communication? Again, you need the broadband and narrowband because you want to put many information in your spectrum. That's why the broadness of the communication path is expressed in the term of bit transfer rate. So a long time ago, we use analog, which we use digital telephone, ISDN, ADSL, fiber to the home, where in Malaysia, this is very far. I mean, this is an old technology. Now we have up to 300 gigabit per second. So this is just the history of the fiber optic, which is leading is very fast, advanced technology, actor of information network. And that's why we say it's leading as a medium in transferring your data. So this is also taken from the uh, 2000 in 2000 from the internet. You can see this is old technology. We use the CAT, ADSL, ISDN. So the orange color is downline, and then for the green is the uplink, downlink and uplink transmission. So here history of the fiber optic, the first time is demonstrated by the John Tyndall in 1870. You can see that the light reflected from the surface. So from this experiment, you can see the light can be propagate throughout the water as your guide. So we can guide this sunlight, sunlight from one energy transfer to one energy, and this is the total internal reflection, the basic idea of the fiber optic actually. So again, this is the history for the fiber optic. Have you seen the Star Wars? Star Wars, where the Hakonnen, he holding the swan, which made by the laser as a weapon, for in the Star Wars movie. So meaning that in Malaysia, the fiber optic came to Malaysia in 2000, year 2000. So there were 40 years gap with the United States and the US. How US technology is so fast and advanced at that time. Compare now, because of the internet, everyone can access the information. So, but still Malaysia lag behind the US, United States. I think it's about 10 years. So what I meant was the United States is very progressive, rapidly. So you can see here during 1913, 1930, the US already developed with this fiber optic to transmit the image through the fiber. And during 1960, the laser was introduced as an efficient light source. This was the first movie, the Star Wars movie, using the laser as the weapon. You can see how advanced are they. So in 1970, all glass fiber experienced the excessive optical losses. This is because of the, you imagine when you have to make sure all light, 100% light going inside the fiber. And we know the glass is made, the fiber optic is made by the glass, and the glass is made by the sand. The sand. So there are two types of fiber optic. One is glass fiber and another one is plastic fiber. So compared to, of course, plastic is a very high noise or losses compared to the glass. So this motivation motivate the scientists to develop the glass fiber that include a separating glass coating. So that's why in order to make the total internal reflection, you must have two types of material for the optical. So you can find fiber optic used in variety of application such as medical environment. So one is like the endoscopy in the hospital. They can check your inside your organ, what happened. So these are the example what the fiber optic can be used. So such as the fiber optic sensor, and this is the endoscopic. And also in terms of gas spectroscopy. So this is the optical and the fiber look like. So is the material is fused silicon oxide, or we call it as a silica, SiO2. So is the transmission is a total reflection of light at the boundary between core and cladding. So this is the core and cladding. So the website, this the picture we took from this website, Kageyama Lab. So what is total internal reflection? So you can see here, this is when you pass through from one dense medium reflecting index to another lesser reflective index. So this will be happen. So in order to get the total internal reflection like this green, imagine from one medium it will go back or reflected back. So you have to make sure the critical angle meet the Snell law, the Snell law, so that the information or the data is 100% reflected back to your fiber. These are the types of fiber. You can use spatial fiber, multiplex fiber, single mode fiber, multi-mode fiber, or spatial mode fiber to accommodate what you need. To what you need. Maybe if you want the signal to go higher, longer distance, you have to use the single mode. How to determine the single mode? By calculating the numerical aperture. If more than 0.7, it is a multi-mode fiber. It's less than the 0.7 numerical aperture, meaning that it is a single mode fiber. So when the optical fiber, and this is a reflection phenomena happen, so you can see the fish very near to you, closer, but actually it's very deep down. So when you look at the water or the lake or the sea, you feel that the fish very near you, but actually not. Don't catch them if you don't have any swimming safety. Because it's very dangerous, because you thought the fish very near you. When you want to catch them, actually you fall into the water or into the sea. So this is because why? Because of the reflection and the reflect. There are two different medium. So this is the reason why the lake bottom appear shallower than it actually is. So how does the fiber optic transmit light? So we know that the fiber optic has two layer. One is the core, one is the cladding. So the reflective index, of course, different because it's they are two different medium reflective index. So you see here the first signal and the second signal, and then you will ask, maybe you are thinking that will they have interference among themselves? No, because we already calculated the angle propagate into the fiber. So how we play this? Remember the Snell law, the Snell law, and also the material for the cladding and the core. It plays very important roles in making sure your signal can reach you. So please enjoy this. Whether you can hear, can you hear?
Yes, Prof. Okay, continue.
Can I? Okay. All right.
Thank you. ماشي بعد لازم يطلعوا هنا. هيدا حاولت وياه ثانية سكرين يسوي سكرين بس شوي لازم بس انت تاخذ الشاشة بس الشاشة هي الشاشة يطلع لنا بس الشاشة مو تاخذ صورة طبعا اللي منك تاخذ الشاشة منك تاخذ كم صورة يعني ارفعها لازم تطفي اللايت.
بس تغير الترتيب.
بس تغير الترتيب.
طبيعي يسوي
هي مسوية هي مسوية سلايد شو بس مو مسوية شير ويندو شير تقريب.
Thank you. So that's the video about the fiber optics. So the next one, why I want to highlight the video just now. How you get data, even though me in Malaysia and Prof Yousif in Iraq. So thanks to the fiber optics. Fiber optics is a backbone or the connector between Asia and also the Iraq. And because why? Because we are separated by the sea and the water and the ocean. So if we want to use the copper, the copper is very in terms of the capacity and also the transmission. We need to upgrade. So very opposite with the fiber optics. The fiber optics are very thin, and then we can lay a lot and many channels or using the fiber optic, and it can reach you. So imagine a signal or the Wi-Fi, you use the wireless, it just can the distance only 100 meter, but the fiber optic can go up to 1 kilometer without any amplifier. So these are the advantages using the fiber optic versus the copper or the wireless. Of course, one of the professor asked me why you still investigating the fiber optic or the photonics in your field. I say because the fiber optic give me secure. In terms of security, I feel secure. Compared to wireless, yes, you can bring your mobile phone everywhere, but it's very easy scam by the scammer and also hack by the baddie or the scammer. So this is why I choose fiber optics. So of course, fiber optics is not perfect. It has losses, such as the material, the thing, because it's natural. You take the sand from our land, and then it become a material to make the fiber, right? So of course, there is absorption there. Absorption. Sorry for the typo. Absorption. So and also it must have the scattering. Nobody perfects. Same like the fiber optics. So the scattering, the absorption, the bending, when you turn the fiber is in the pulling, so there is a bending, it can give you loss, noise, scattering, all this contribute to the signal degradation. I mean, the signal strength become reducing. So so this is, I say, why there is a transmission loss for the fiber optic. I mean, this is natural. So from the physics, this is the water absorption, the dispersion, and this is the IR absorption. You can see here, this region 1.5 is the lowest absorption loss. That's the reason why the center wavelength for the fiber optic at the seabed, between 1530 to 1565 and nanometer. So normally our fiber optic center wavelength at 1550 nanometer. So the short wavelength and the long wavelength, we have the absorption. So loss peak at 1.4. You can see here, you see here the light, the highest water peak at the 1.4 and the lowest absorption peak at the 1.5, 1.53. So this is the reason why you choose the 1550 as the center wavelength center in transmitting your data. So because the water vapor, the scattering, this is all natural. It occur in our life, which we cannot stop this from happening. So number two just now is the loss, the absorption. So number two is the attenuation and the dispersion. So attenuation is reduced in the light amplitude. Why you need attenuation? Or in your setup, in your experiment, the component attenuator, because you want to protect the equipment from damage, damage with the excessive input power. When the power is very high, it will damage your device, and that's why we need the attenuator to reduce the amplitude. But in the natural effect, the attenuation make the strength, meaning like this, the tall becomes shorter. So this is the attenuation. And for the dispersion, you can see from very thin and very slim, it become fat. So fat, this is because of the dispersion. For example, 101, it become 111. So the signal is not accurate because we know the information must be very precise, concise. If not, you will get a wrong signal. Wrong signal. So when the distance, this signal travel one distance, it will become shorter and fatter. Or in this word, in technical, we will say the signal is attenuated and also dispersion happen. So how to boost back the signal? You have to use the amplifier. So you know the amplifier, like the semiconductor amplifier, will induce the loss or the noise. So that's how we will use the erbium dot fiber laser fiber amplifier to boost your signal. So in fiber optic technology, you know, you have three components, very important. One is the transmitter, and the other one is the optical receiver, and most important thing, the fiber optic cable as your medium. So without an optical receiver, you cannot receive any signal. And with the cable, it will make sure your signal can reach you 100% or less than. I mean, if you want to less, it's 99.9. That's the reason. So let us talk the source of light. The example for the light. For example, the light emitting diode, the LED only cost us 10 cents. 10 cents. and also the laser. And these two, and what's the difference is the emission. Laser is very powerful, while the LED is also have the light, but very small, small intensity, which cannot damage your eye, okay, your eye. So why so important the light source? Because we use it to modulate the electrical signal into the optical signal, meaning to say it's also as a media converter, convert electric to optical or analog to digital, digital to optical. It's very easy. The optical is on off, on off. But the analog, you know, the difference between the analog, the digital, and also the optical. For the optical, it's very straightforward. 0 volt or 5 volt. So mostly you modulate F850, 1300, and 1550. Because why? These are the among lowest peak of water vapor. Remember the natural, behavior for the water vapor, the air. So that's the reason why we choose the 1550 nanometer as the center wavelength. So the laser gives you high intensity, high frequency, high coherency, and narrow bandwidth, narrow line width. Meaning that the laser that we launched is very sharp. When it's very sharp, meaning that you can go longer distance. Compared to the LED, very economic. This is the advantages using the LED because it's very cheap. Compared to laser, very expensive. But expensive, you can use the laser to get longer distance. So this is the transmission medium, and you know the fiber optics we use to replace the copper, coaxial cable, the twisted pair. No one can challenge the optic fiber so far, the optical fiber. So the light is used as a carrier of the fiber, and uh, you can carry a very higher data rate. So this is the speed. You want very high speed, very fast. In order you to talk to someone, not in front of you, but behind the screen or on your screen, like this. I can reach you because of the internet. But what is the medium you use? Of course, the for fiber optic to the wireless or the RJ45 cable to your laptop. So this is the physics of the optical fiber. We have we mentioned that the index of refraction of the material must be different, so that the total internal reflection can be happen. So refraction, what is refraction? What is reflection? So refraction is bending of light as it travel from one medium, from the denser refractive index to a less refractive index. So this is a refractive index. You know that the vacuum is 1. Normally in the exam, we will give the student the value for this refractive reflection index. So why we need? Because you need to calculate whether the Snell law you can apply it. So this is the Snell law, or using the Snell law to get the total internal reflection happen. So from here, from the fast, medium, smaller index to the higher, the slow, medium. So you have to inject or increase the medium in order to change the critical angle. So it happened with the angle of refraction equal to 90 degree. 90 degree. So again, why you need the total internal reflection? Because you want to trap the light inside the fiber. Yeah? You want to make sure 100% of data or information inside the fiber. This is why the what the reason of reflection. Yeah. So the fibers can be bent, of course, but you have to very careful because it's very fragile. It's a glass. So you actually you can see from the YouTube. It's normal that during my class I will share some video. So one for me to take 1 minute or 2 minute break, and then number two, the student he can understand from the visual presentation, right? So you can imagine, oh, this is what happened, because we know our slang. I'm not 100% the London or the US slang in speaking English. And also we also have our own mother tongue. So this is the important why we use the YouTube to assist in our teaching. So this is types of fiber. We have single mode and multi modes, and also the losses. We have attenuation, dispersion, and also the waveguide, and also the loss. So when one fiber to another fiber, you want to connect them. So you have two action or two procedure that you can use. One is using the splicing machine, and then the other one is using the connector to connect one fiber to one fiber, because you want to make a very long fiber, right? So you can connect the fiber mechanically or by fusion. By fusion meaning that you use fire to melt the fiber, and then it will merge together. However, when you connect with one another, it will incur some losses. That's why a lot of signal loss possible. Possible. So alignment, you also need to make the alignment same like your car tire. When the car move or travel very long, you need to align so that the signal your car in a good shape to work in front or move forward. So of course the cost is a factor. So now we also have the amplifier, and how to amplify the signal is also very important. So lastly, the optical receiver, very sensitive. A very difficult part when you design an optical fiber system is on the optical receiver. Because why? Because it's very sensitive, and then this device can turn on only by light. So it's produce current and photo current. It's very small, and this small current, how are you going to amplify? So this is the challenge when you want to design the optical receiver. So these are some of the example for the photo detector, such as the pin, the APD, the avalanche photodiode. So you can see here, you can see like a solar panel receive the light from you, and then it's a light a diode or transistor diode to convert your signal from the voltage to the photocurrent. So of course the modulation when you're sending information by an fiber optic or optical fiber, you have to transform or encode it into something that you can read. Something that you can read. So there are two types of modulation. You have TDM, you have FDM, FM, frequency modulation, amplitude modulation, time modulation, up to you. Up to you, you design. So the important for this course is teaching you how to become a network designer or engineer. engineer, network engineer, to design for your customer by knowing these three elements, which are the light source, the medium, and also the receiver. So again, I would like to give you the summary, the advantages of using the fiber optic, because you can carry more information and with higher data rate and longer distance than the coaxial cable or the old cable, and immune to the electromagnetic field noise, very light, very easy to bring everywhere, and it's also is not affected by the atmospheric agent. This is an example for the wireless. You know, when heavy raining, you cannot get the signal, right? So this is one of the disadvantage when you use the wireless. So some of the advantages fiber optic over the wire cable is thinner and again non-flammable, and also is very secure. Very secure. However, the fiber optic also has this advantage over the copper wire, because it's very expensive, and then it's not, it cannot join easily like the copper. You can just twist the wire, but the fiber you need the splicer machine to splice them. Of course, the splicers is very expensive. I remember we bought one splicer machine that cost us one car, one expensive car. So this is to show that how the fiber optic is so expensive. So this is the assignment. So with that, I end my topic. With thank you. Thank you. Anything you can email me with this NOA at ucam.edu.my. So Prof Yousif, I pass back to you. Thanks for this and for listening.
Thank you very much, Prof, for this very interested lecture and very deeply and detailed information about fiber optic as a technique and as implementation. Thank you for your effort. Now we'll listen to some question or notes from the attendance. Also, I forget in the attendance Dr. Muhammad Al Osaj, your students, the last your students.
Oh yeah, yeah, he's
Dr.
here.
Muhammad. Yeah.
Dr. Arsad?
Hey, Dr. Osaj, yes.
Oh. How are you?
Fine, thank you.
I think with Dr.
لا منين لا بس سوي سكرين.
So Dr. Arsad is the lecturer for the optical communication, right?
اغلق المايك. Yes, Prof. Yes, continue.
You teaching this subject? Are you? Are you teaching this subject?
تسألك تقول لك درس الموضوع.
I hope I to study this subject, but till now there is no subject in. Maybe in next year, inshallah,
Okay.
I will study this subject. I have some questions for you, Prof. The first question: if I have data to transit for 100 kilometers, which is suitable for cable single mode or multi-mode and why?
Yeah, of course. It's a very tricky question actually. We normally in Malaysia, we will use the single mode fiber for the 100 kilometer. So in order to reach you the information. Yeah.
Okay, the second question. For the refractive index between core and the cloud. If we use refractive index for clouding bigger than for the core, this is suitable or not for the cable?
Again, Dr. Arsad?
I use the refractive index for cladding 1.55.
Low what?
1.55 refractive index for cladding, and use 1.50 refractive index for core. Is this suitable or not? And why?
For the reflective index, right?
Yeah, for the refractive index.
No, you have to have different refractive index for the both core and cladding.
I know you have the more refractive index, but I asked if the refractive index for the cladding bigger than for the core. Is that suitable for key fibers
Yes,
optic
yes,
cable?
yes. I think so because I cannot get your full. It is like a anchor voice reflection black.
Okay, but I think must be would be small than, not bigger than for the core.
Yes, yes. I think yes. I agree with you.
The last question for the splicing and connector, which is suitable to join
Okay,
optic cable, splicing or connector?
the splicing. The splicing, because why? If you use the connector in one side and the other side, it will induce loss. Compared to only one point. So it's we go for the splicing.
For the splicing, the suitable from the connector because the losses is small than from the connector. Okay, thank you so much.
Yes.
Thank you.
Thank you. When are
Bro,
you coming to Malaysia?
Prof. Dr. Muhammad asking us same as Viva question. When he's make online Viva.
Yeah. Please come to Malaysia.
Thank you.
Thank
Any
you,
question
Prof.
more, please? Excuse me, Prof. I have a question about the about the biomedical sensor with the fiber optic. Because now the project work together with Dr. Muhammad and Dr. Becker about EMG, electromyographic signal. This I have three sensor wireless, and then I need connect with the fiber optic to transfer the signal more than the range of the wireless. About the losses when the touch between the wireless and fiber optic. What's the best technique for this injection for the signal? Between the
So when you say the
yeah.
So when you say there's a conversion between the wireless and also the fiber optics, right?
Yes.
The conversion, okay. So normally we will use the speed of light c equal to f lambda for the conversion between the wireless and the optic. And then I think you remember the one of our project with Dr. Muhammad Jawad?
Dr. Mohammed.
Yes, bro.
We discussed about the injection of the signal between the wireless biomedical sensor
Yes.
with
So
fiber
machine
optic,
learning,
because the traditional technique will different the sampling for the take data from the muscles and the fiber optic, because fiber optic faster than the wireless bio signal. Therefore, in modeling, now I apply the modeling and then apply simulation and then go to implementation. In the simulation, the different sampling between the wireless biomedical sensors and the sampling for the transfer the signals in fiber optic. Therefore, this injunction was the best solution.
Of course, the best solution is fiber optic.
I know fiber optic for transfer, but junction between the wireless signal from the biosensor to fiber optic receiver, and then transfer in the fiber optic. No problem about the fiber optic transfer. Well, I know the best solution for high range about the transfer the data. But now when I apply modeling and try to apply simulation in MATLAB, make problem in injunction the signal between the biosensor, different sensor. I now use the electromyographic sensors to injunction with fiber optic. The different sample maybe lost much information because the different sample.
Yeah.
What the best solution?
Because of the conversion.
Yeah. What the best
Because
solution?
of the conversion.
Yeah.
That's why you can use radio over fiber.
I can use the 24 line in fiber optic, no problem about this because I can transfer one by one serial, not need parallel, no problem. Just the problem about the injunction between the different of sample because I not need lost the information from the biosensor.
Yeah, yeah. So we are still looking for into this with that's why the Dr. Muhammad Jawad, Prof, you remember? That's the
Also,
student.
yeah. Also, I not need the offline transfer because if I summing the data in buffer and then transfer, this no problem because I need online because I need monitoring the activities of the human
and
online in center. This is a problem.
Laser. So in this case, the must be laser. When you send the Wi-Fi or wireless for the fiber optic, I think you can. Must be for the detector or must because Wi-Fi you can't send the signal in laser or other, right?
Now I try all the type of the detector in fiber optic, different the sampling. Therefore, when different the sampling, many information will lost in injunction process. Therefore, no synchronize. This the big problem. This we need solution.
Because it's received just back, not
What the solution? This big problem. This need PhD students, Prof. Maybe more than one. Not,
there's
not one.
one student is coming.
Yes, Merci Yasemin. Also available. Just Dr. Mr. Ammar. Also, Merci Yasemin in our department.
Jasmine, right? Jasmine.
Yeah.
How are you? So we are waiting for you.
Maybe we'll try.
Fine, Alhamdulillah.
Maybe
we are
we'll
looking for you,
try
looking
solution
forward
with
to
this
seeing you.
Merci Yasemin.
But my next project about control. I'm not interested in communication now.
Oh, okay, communication. All right.
Control.
And control, that's why we will use that to become the photonic technology.
Yeah.
Sensor.
Yeah, Mr. Yasemin will use the
And
fiber
Prof?
optic just multimedia.
Yes.
For transfer the signal.
Yeah.
Therefore, we'll try to solve this problem with Mr. Yasemin. Inshallah.
Inshallah.
Because we'll use many sensor in robotic to transfer the workspace of the robotic in other place. Therefore, we need inject the signal from the sensor and then in transfer in fiber optic. Therefore, maybe get the solution, inshallah.
Yes, inshallah. Yeah.
Inshallah. Excuse me, any question more? Thank you, Prof. Thank you for your
Thank
time.
you.
Thank you
Yeah.
for your effort. I hope, inshallah, accept for your prayer, inshallah. Thank you very much.
Inshallah. Please do come visit us, Malaysia.
Also,
And
Dr. Muad, head of our department, you need take thank you for you, Dr.
thank you,
Muad.
Prof. Yeah, thank you.
Thank you, Prof, for your lecture. For making. We hope also near the future. Thank you for your lecture.
Thank you, Prof.
Thank you, Prof.
I wish all Ramadan Karim. Is it Ramadan Mubarak? Is it?
Inshallah, for you.
So
Thank you very much.
yeah,
Thank you.
yeah.
Salam alaikum.
Assalamualaikum.
Salam alaikum.
Salam.